All right, we're back. We are on page 81 of math analysis, and we're talking about using u-substitution to make a challenging looking problem a little bit easier. And so what we're going to do is go through that process and then check them on the calculator. And it's really this entire page. I don't know how many we'll get done in this video. Depends on how it goes. Sometimes I think we'll get a lot, and sometimes I know that we won't. So let's see. First thing I'm going to do is I'm going to say let u equal 3x minus 4 pi over 5. So you don't need to do that. Like, you can just kind of think your way through it, and maybe I'll do that on the next one. I don't know, but I didn't do it on this one. So this becomes 4 tangent of u plus 3 equals 0. I mean, it just looks like a simpler problem. We're going to solve the simpler problem. Get the tangent of u is negative 3/4. All right. So tangent, and it's negative. What do we think about? We want to know what quadrants it could come from. So tangent negative, it could come from here, or it could come from here. I'm also thinking, because I'm going to find a reference angle, and I'm thinking of the way that that works, right? So because it's tangent, and the quadrants where it's negative are opposite each other, they're not adjacent to each other, I guess. They're like vertical angles from geometry, anyone? The reference angle is going to be the same. Like this and this are the reference angle, and the two angles that we're talking about just differ by pi. So I don't need two different formulas. I only need one. So what I'm going to do is I will find the reference angle. So the reference angle is going to be the inverse tangent of the absolute value, so of 3/4. And then I'm just going to make sure that I put it in the right quadrant and kind of go from there. So there's a lot of ways that you can solve this. Another thing you could think is like, oh, I know the inverse tangent of a negative is a negative quadrant 4 angle. The inverse tangent of negative 3/4 actually would give you this. And you're safe. You could actually just do the inverse tangent of negative 3/4 and then plus pi times n. It works. It's a little riskier though, I think. So I'm going to choose not to do that, but you could. What I'm going to do instead is I'm going to say that it is u is equal to, so second quadrant, I'll do pi minus tan inverse of 3/4, the reference angle, but then I have to generalize, right? So the period of tangent is pi, so plus pi times n. I know n is an element of the integers. Sometimes I just save that until the very end. It depends on how many steps I'm going to have to do, because I don't want to have to write that a million times. So now what I'll do, whoa, excuse me. I didn't even change. Okay. So now what I'm going to do is I'm going to change this u into 3x minus 4/5, 4 pi over 5. I'm going to try to get a common denominator anywhere like possible, but there's really not a lot that we can do. So what is that? 3x minus 4 pi over 5. So I can change, what I can do is I can change pi into 5 pi over 5, just so it's like easier to see what I'm doing. And inverse of 3/4 plus pi n. Okay, I'm gonna skip it. I'm not gonna write n as an L. I'll put comma, just so we like remember. So now I need to add 4 pi over 5, and then I need to divide by 3. So I'm actually gonna do that in the same step, I think. So I'm going to end up with x equals, so I add 4 pi over 5 to both sides. There's only one like term with that, and it's 5 pi over 5. So I'm going to add 4 pi over 5 to this, and then this will stay the same. Then I'm going to divide everything I have by 3. So adding 4 pi over 5 gives me 9 pi over 5, and then dividing by 3 gives me 9 pi over 15, minus I'm dividing by 3, tan inverse of 3/4 is its own thing. Like you can't, there's no way to pull the like 1/3 inside the parentheses or anything like that, which I've never seen anyone try to do. So hopefully you're not going to be the first. N is an element of the integer. So this, I think, is my solution. So what could happen, I mean, obviously I could simplify that, the 9 pi over 15. I also could potentially have just used, so since I could have just used, how to best explain this? Since over here, this is the tan inverse of negative 3/4, as long as you're rotating, I should have done that in a different color. As long as you're rotating this way, it is that. So I could have, it's a little simpler to just use tan inverse of negative 3/4 and then go from there. It's a simpler solution, but it's not more right. So let's see. I'm going to switch over to the calculator and check it and see how we did. So I need a new calculator page, and I'm going to choose, what should I do? I'm going to do 4 tangent of 3x minus 4 pi over 5 plus 3. And I need it to be 0. So I'm going to say such that x equals 9 pi over 15. So I don't like lose any sleep about simplifying these kinds of things. So, ooh, this gave me 3. This did not give me plus 3. Oh, look at me. I didn't put in the whole thing. I don't really simplify fractions. I'll do it if I need to. I forgot to put in the arctan of 3/4 divided by 3. I mean, come on. Come on. All right, let's sub this in and see what we get. We get 0. That's what we were supposed to get. And then if we add pi over 3 to, that was weird because like when I was doing it, I didn't feel like I made a mistake. But then when I typed it in and I got it wrong, I was like, uh-oh. And then if we add one kind of period of this particular function, which is pi over 3, we still get 0. So we know that we got it. We could also use solve. I'm going to try to copy and paste this down. Solve this equals 0 for x. Let's see what it gives us. Holy cow. Okay, so when this happens, one of the things we might not be able to get the exact value, but sometimes you can on the outside. So what I'm going to do is I'm going to limit myself between 0 and 0 and 2 pi, and just let's see what it says those values are. And they might be exact values, hopefully. So 2 pi, 0 and 2 pi. No, I can't do it. I can't get the exact value. How about 0? Oh, 0 and pi over 3. Let's see how many are. Nope, man, why will it not give me the exact value? I do not know, because it should, I think, be able to here, but it's not. But whatever, we know that it's right. So solve maybe not the best way to check it in this case. I'm gonna do another one. Let's see. So I'm gonna try to skip the u step in this case. It's such a useful thing though. Like I feel bad skipping it because you know, you want to develop good habits so that when things aren't as easy, you already have those habits, that like habits of mind, so that you're using them. So I guess I'm gonna do it is basically what I'm saying. But I'm gonna do it up here so that it's not as in the way. I'm gonna say let u equal 3 pi over 4 x plus 1. It makes the problem look a lot simpler. So 5 cosecant of just u plus 7 equals 17. So cosecant of u. So we subtract 7, get 10. Divide by 5, we get 2. So I'm going to switch that because I do not want to deal with cosecant. I'm just going to say sine is 1/2. Famous, right? We know this one. So you can think of this in any number of ways. I prefer to think of it as, I know that it's pi over 6 and 5 pi over 6. Just kind of like move on. But if you don't know that, then you're back in this world, which like you want to visit this world every once in a while, even if you do know what you're doing. Again, it's the habits of mind that you're trying to develop so that when you get to the hard problems, you're just like on autoplay. So we know that, we know our reference angle is pi over 6. And so we know the angles are going to be pi over 6 and 5 pi over 6. So u is pi over 6 plus 2 pi n. And u is 5 pi over 6 plus 2 pi n. Okay, so now what do we do? Well, what we want to do is we're going to replace u. So we're going to replace u. Sounds mean. But what I do? Well, you're not right. You're just not right for this position. So we're going to make u equal 3 pi over 4 times the quantity x. Auto. Why? So auto shapes are so weird. You can't hit back when it auto shapes. If you try to hit like back, like undo, it doesn't acknowledge it. It's like because you didn't do it, I guess. So this equals pi over 6 plus 2 pi n, or 3 pi over 4 plus 1 equals 5 pi over 6 plus 2, come on, 2 pi n. Okay, so I like to put the comma when I remember to indicate that I will be putting n as an element of the integers, but I don't want to write it a lot, so I've skipped that. So here's why, so important that you generalize as soon as possible, because what I'm about to do is I'm about to multiply everything I see by 4, everything, including the generalization. Then I'm going to divide everything I see, including the generalization, by 3 pi. So we're doing all of that. And so if you didn't generalize soon enough, you can't just throw plus 2 pi in at the end. It won't work because you've got to do all the transformations. So let's see what happens. So I'm multiplying by 4, dividing by 3 pi. So that dividing by pi is going to knock all the pi's out. They're gone. If you don't like the way I'm doing this, just show all the steps. Totally fine. I'm going to multiply by 4. That gives me 4 over 6. Divide by 3, that's 4 over 18. So I'm going to say x plus 1 is 4 over 18, which I'm aware is 2/9, but I don't really care about it right now. Multiply 4 times 2 pi is 8 pi. Divide by pi, the pi is gone, so that's 8. Divide by 3, 8/3. So plus 8/3 n. And then, so x is going to be, so I'll make it 2/9. 2/9 minus 9/9 is negative 7/9 plus 8/3 n. And then over here, it's going to be the same idea. So I'm going to multiply by 4, and then dividing by pi is going to knock out all the pi's, and then I'm going to divide by 3. So multiply by 4, I get 20 over 6. Divide by 3, I get 20 over 18. So we're going to have x plus 1. 20 over 18, I'll say is 10/9. And then 8 pi divided by 3 pi is plus 8/3. And so if you do them kind of separately, you know, like I did the first thing where it was pi over 6, blah, blah, blah. If you actually do all the work, which I recommend, it kind of checks itself. Like you usually get the same denominator, all kinds of good things like that. And you know, you'll know if your generalization is right. And I'm just going to say n is an element of the integers, kind of like in the middle, maybe more in the middle, so that it's like obvious that that's what I'm going for. So our answer here, we got a lot of answers. 2 types. So we got this, and then we know that n is an element of the integers. So let's go check this and see how it worked. And hopefully we got it. I think the calculator will be able to solve this one. Tangent one, I'm not really sure. Let's see. I mean, maybe it won't be able to, and you know, that'll explain nothing, but at least I'll know why it didn't solve it. Solve 5 cosecant of 3 pi over 4. Quantity, x plus 1 plus 7, okay, equals 17 for x. All right, good. So what is happening here? I'm going to use expand, which remember, so expand, it's way faster to type expand. Menu 3, 3, and then I'm just going to pick this, press enter. So it gave me -7. Oh, I got -7/9. Okay, that was one of the answers that I got. I thought that I'd gotten a different version. And then 1/9. So definitely got it. All right. So I'm going to go back to the notes, and I think I'm going to stop this video here and come back in the next one and try to do more of these. I don't really know what. Maybe, you know what? Maybe I'll do one more, because I think there are 6 on the page. There are. So like, makes sense. I'll do this one while we're here, you know. Nobody's got anywhere to go, right? So I'll skip the u thing. So I'm gonna a slightly different way of doing it. So here we go, secant of, so I do a lot of just calling it this thing. Secant of this thing is equal to, subtract 1 and you get 10, divide by 4, you get 10 over 4, which is 5/2. So then I'd rather use, would I rather use cosine? I don't really care because it's not like famous. So I'm just going to leave it as it is. ASTC. Secant, and it's positive, so from here or here. Reference angle is going to be the secant inverse of 5/2. So I mean, we're going to get a messy answer, which is, you know, totally fine. So that's our reference angle. So we've got our, let's jazz it up. Quadrant 1 solution is going to be 3x minus pi over 5. Right, so the secant of something is 5/2, which means that something could be the quadrant 1 thing. So the something is this, could be equal to the first quadrant angle, which is just the inverse secant of 5/2. Or it could be in quadrant 4. I do not like the way that these are lining up. Here, I'm gonna move this up. It's all about your lining up your solutions. So here we go. Quadrant 4, I'm gonna say that thing that we're taking the secant of could be, so I have a choice. I can get to quadrant 4 in 2 different ways. I can go all the way around and then subtract the reference angle, which is like doing this. So like we want to get here basically, right? So one option, I go all the way around and then subtract the reference angle. That'll be 2 pi minus the reference angle. Or more directly, I could just go this way and it'll just be the negative of the reference angle. I'm going to choose to do that because it's a little less writing. And when you are doing this, anything that's less writing is just like, yes. Oh my God, I forgot to generalize. What? Okay, hold on everybody. We're gonna be okay, maybe, hopefully. I think it's because I started thinking about the spacing. Maybe, that could also be an excuse. If you watch enough of these videos, you'll find out I'm full of excuses for why I've done or not done various things. All right, here we go. I am going to add pi over 5 and divide by 3. There's nothing to currently add pi over 5 to. There's no like term. So it's just going to be pi over 5 divided by 3 is pi over 15. Secant inverse of 5/2 over 3 plus 2 pi over 3 times n. So that'll be x there. And then here, same deal. We'll get x is add pi over 5 divided by 3 is pi over 15. There's no like term to collect that with. Secant inverse, which is our reference angle, over 3. And then plus the 2 pi has to be divided by 3. So if you think you're just going to throw that in at the end, you're gonna be getting some wrong answers. So I think our answers are this and this. And then of course, n is definitely an element of the integers. If you don't put that, you are wrong. So make sure you're putting it in. Let's go to the calculator and check this. This is like, I almost ended the video and then instead I spent probably another 4 minutes in the video. Solve for secant of 3x minus pi over 5. So this is what I expect you to be doing when you are working on problems on your own. Like I do the problems right in front of you and then I go check them. Like if you're working, oh my gosh. If you're why did I have to use arc sign? Let's do decimals. You know what? Let's check our own answers. How can I do that? I need to like cut that and then paste it maybe. It doesn't really like to let me paste. Woo! All right, I'm gonna just plug in my answer. So yeah, when you're working on your own, I expect you to be checking your answers. Like don't be lazy. Like you don't have to ask other people. You have this calculator that can do the work. All right, arc secant of 5/2 over 3. And then I'll just add 2 pi over 3 like right off the bat and see if it worked. So it gave me 12, which is what it should have given me. That's one of them, but there's another type, right? And all we have to do is change this to a minus. Also gives us 12, so we got it. All right. So using solve on that turned out, the answers just look so different and I didn't want to be bothered with like showing that they're equivalent. So that's why you want to know multiple ways of doing it. So I went to plan B really quickly as soon as I saw that arc sign and I had not even begun to touch that. All right, so I'm going to end this here. I'll come back in the next video and do some more. So I will see you there.